Hi all, welcome to the video. In this video we will look at how we can represent a discrete random variable in R and how we can discuss and study some of the properties related to it, specifically the probability distribution and cumulative probability distribution. Okay, so let's try and simulate a dice. So how we can do that? So dice is, if you look at, there are only 6 options possible or 6 output possible in a dice. So this is basically 1 through 6. Okay, now let's say we are trying to roll a dice 100 times. So we'll just represent 100, and each time we have the option of replacing. By replacement we mean that the option that was that showed up in the last run is can still occur in the next few outputs. So we are just using replace as true. So let's make it 10 so that it is easy to understand. Okay, so you see, the first time I threw a dice, it came as 2 and then 6, 2, 5, 2 and so on. So just to make it a little simple, let's use SMPL, a variable, and use SMPL here. Okay, now in order to visualize the probability distribution, we'll basically create a data frame. So data dot frame. Okay, so let's assign line number 6 to X and basically face. Okay, now let's try to get the count of the times each face appears in the roll of a dice. So what we are going to do, we are going to group it by. So before using group by, you have to basically import the library dplyr or tidyverse. Now we have to group it by phase, and for each phase we want the number of times total count. So you see, 1 appeared 2 times, 2 appeared 1 time, 3 also appeared 1 time, and so on. If we add it up, it basically becomes 10. Now we just need to ungroup it, and then let's also calculate the cumulative distribution. So this will be equal to total count divided by SMPL. Okay, what's happening? Oh, sorry. So we have to do a cumulative sum also. Okay, let's see. So you see, for each phase, as we add up the total probabilities, it ends up at 1. Now we have the data frame, let's call it as TF2. Now let's try and plot the probability distribution. For this we will be using ggplot library, so again import it before running the code. So we will do ggplot. So data is nothing but TF2, and then we have to specify the aesthetics. X will be equal to phase, y will be equal to total count, and stat equal to, okay, let's see. Okay, now you see the probabilities. If you remember, in all statistical problems, the probability of 1 when a roll is diced will equal to 1 by 6, and the same is true for all the other phases. However, in this you see, if I am rolling the dice 10 times, the probability seems to be a little different. The bar should be of equal size, right? We will see that how that can be done. Now the same thing we will do for cumulative distribution. So instead of total count, we'll just specify. Okay, so if I add this up, it essentially becomes 1. Now the law of large number, it states that as we increase the probability, in the long run it approaches its class, each probability of each phase approaches its classical value, which is 1 by 6. Now let me do it as 100. Now let me, okay, now let me do this at 1000. If I do it at 1000, let's see. Now you see mostly the bars are approaching equal length. Now let me do it as, okay, so you see as I increase the total number of times a die is supposed to be rolled out, it the total occurrences of each phase, assumes an equal proportion. So this is essentially the law of large numbers. Now you see, using a very simple example, what we did, we represented a discrete random variable, the discrete random variable being the phase of the die once it is rolled out, and then we sampled it for like 10,000 times, and we then plotted its probability distribution and cumulative distribution. I hope this video was useful to you. If you liked the video, do subscribe to my channel.